block of mass 53.1 kilograms rests on a slope having an angle of elevation of 22.3 degrees. If pushing downhill on the block with the force just exceeding 167 newtons and parallel to the slope is sufficient to cause the block to start moving, find the coefficient of static friction. So basically we're trying to find the coefficient of static friction, which is max, because any more force applied would cause the object to start moving. So we have our mass is 53.1 kilograms, our angle of theta is 22.3 degrees, and then our force applied, FA, force applied, is 167 newtons. So in order to find that coefficient of static friction, which is represented by mu s, you can use the equation, the force of static friction is equal to the coefficient of static friction times the normal force. Well, how do we find the normal force? And we can do that by taking the sum of forces in the y direction is equal to the mass times acceleration in the y direction, Newton's second law. And since there's no acceleration in the y direction, this will equal 0, which means that this equals 0. And sum of force in the y direction also equals the normal force minus the mass times the gravity. And that equals 0. So the normal force is actually equal to mass times the gravity. So moving over to our chart here, we have the normal force going up, our mass times gravity going straight down, and the force applied going down, the force of static friction going up. And the reason n is crooked like this because it has to be perpendicular to the slope. So we need to find n from mg. And they are equal, but if you look at this, you might think, well, that doesn't look equal, and you'd be right, because since these vectors are not equal, we need to find, this is our theta, by the way, we need to find the y component of mass times gravity, which is right here. And this angle is actually equal to this angle, so that's theta. And how can we do that then? Well, we can take mass times gravity times the cosine of this angle, which is 22.3, and that will give us our value for n. We're taking the cosine because we need to find the y component here, and it is adjacent over hypotenuse, and the hypotenuse is mass times gravity. So mg cosine of 22.3 will equal n. You can just type that in right now. So our mass is 53.1, and gravity is 9.8 meters per second. So 53.1 times 9.8 times the cosine 22.3. That's going to give us a value of 481.46 newtons. So now that we have our n, we can solve for the sum of the forces in the x direction. So the sum of forces in the x direction is equal to the mass times the acceleration in x direction. And since we're looking for the static coefficient, or the static coefficient max, friction coefficient max, there's going to be no acceleration because we're going to need a little bit more force to get the object moving so it is still at rest. So this is actually equal to 0. There's no acceleration yet. That means this is equal to 0. So our sum of forces in the x direction is equal to 0. Now we can find the sum of forces in the x direction, and we have the force applied, which is 167 newtons, and we take that plus our mg x component, because that is parallel to the slope. That is the force acting downwards from the mass times the gravity, and that equals mg sine of 22.3. because it's opposite over hypotenuse now. So 53.1 times 9.8 times the sine of 22.3 gives us a value of 197.46 newtons. So we can add that here, 197.46. And then our final thing in the x direction is going to be the friction of static friction. And that's opposite, so it can be minus Fs. And since Fs is actually equal to the mu Sn, we can replace Fs for mu Sn. So, and that is equal to 0. So now to find the ms, we add that over. Mu Sn, divide by n, which is 481.46 newtons, and it'll cancel on this side. So if we just type this in, we'll get the coefficient of static friction. So 167 plus 197.46 divided by 481.46 gives us a value of 0.757.